Okay, hello everyone. Today we are going to see a new DFA problem. Construct a DFA to accept the string of A's and B's starting with a substring AB. Okay, so we want to design a DFA that going to accept all the input starting with A and AB together. Okay, so as usual, we'll start with the Q0 state. So Q0 is the starting state. We'll put arrow mark to denote it's a starting state. So it should start with A and B. So we'll take the first input A and we have a Q1 state. Okay. It'll have a one more state B. So it'll go to the Q2. Okay. So after AB, starting with AB, it can continue with any number of A's and B's. So what we'll do before that, we'll make this one as a final state and we'll self loop A and B. Okay. Because it should start with A, it should continue with B, and it can have any number of A and B. Okay, now we'll quickly plot this into a transition table. So I will plot transition. So we have a Q0 state, we have Q1 state, and we'll have a Q2 state. So again we have a input and B input. So this will denote this one as a starting symbol and this one as a final state, that is Q2. So whenever we have a Q0 on A, it goes to Q1. So Q0 on B is not yet defined. Same way Q1 on A goes to, is still not yet defined. So Q1 on B goes to Q2. So same way Q2 on A goes to Q2, Q2 on B also goes to Q2. Okay, so now we have left out with two states. We'll try to fill it up. But what is the problem here? So it should always start with AB. So I can't self loop the B. Okay, we'll try to self loop the B, but that is not possible. So what we'll do, we'll take one new state, that is Q3. Okay, we'll take one new state Q3 that goes B. Again, same way in the Q1 also, we can't continue here because in the middle, if we change, the AB logic goes up. So what we'll do, Q1 on A will put into a new state. And this state is called as trap state. Okay, trap state or a dead state. So what is trap state or a dead state means? From there, we can't continue and reach the final state to stop our machine. So if it goes to this state, it keeps on loop there. For that one, again you should put one self loop A comma B so that it continuously loop there whatever the input it gives and the machine won't stop. Unless until the machine goes to the Q2 state and stop, it is not acceptable by the machine. Okay, so what we'll do, so this is called as Q3 is a trap state. So now we introduce the Q3 into our transition table. So Q3 on A, again it goes to Q3 itself. Again Q3 on B input, again it goes to Q3 itself. Okay, so now we fill out the left out blanks in the transition table. So Q0 on B going to Q3. Okay, and same way Q1 on A goes to Q3. Okay, so that what this problem exactly means, so we have one condition, means our finite automata should start with A and continue with B. So by chance, unfortunately, if it is starting with a B, it goes to the Q3 trap state and it keeps on take the input, but the machine will not stop. Okay, so that, so we created this trap state to lock the unwanted trap. So another way we can skip this part. Okay, if you skip this part, we can't fill the transition table completely like this. If all the cells, each and every cells of the transition table is filled and with only one state, then only we can say that it's a DFA, complete DFA, because each and every state on each and every input, it should have a determined state to reach up. So then only we can call it as a DFA. So to make sure that we create the trap state and fill the table and made this complete diagram as a complete exact DFA. Thank you for watching. Subscribe and like for more such videos.